Hey YouTube, welcome to the next episode on First Principles. So just a quick recap of what we did last lesson. So we looked at the theorem that the gradient of any curve at any given point is the same as the gradient of the tangent at that point. So what we did was, this is the last example we did in the last episode. So if you missed it, please check it out. And we said there's this red tangent, which is an approximate tangent through my sketch. And we wanted to find out exactly what the gradient of it was. And we used this purple chord to approximate that. We found in terms of h was a small change in the x values, and we reduced that value to get a better approximation of the red tangent by reducing these green points, by moving them towards the point that we're interested in. And what it did was it made the chord, it reduced its gradient towards the red tangent. So if you missed that, then make sure you watch that episode before you look at this one, because now we're going to look at generally how does it work for any kind of function. So let's look at how we do this process generally. So say we want to find the general gradient at any given point of some function of f of x. Now for my diagram, I'm just going to say this point here, this general point. Now this general point will just have some x value, then this y value will be some function of x. So here I've said y equals f of x, some general function. So if f of x was x squared, then you would take the x value, whatever it is, and you'd sub it into x squared. Now, we want to approximate the gradient of the tangent at that point. So if I was to just draw some approximate tangent, it might look like this. I want to find the exact gradient of that tangent. But what we said last lesson is we can't do that. We can't draw an accurate tangent. So what do we need to draw a straight line? You just need 2 points. So we just drew or added an extra point here in some random place on the curve. So if we look at the x value here and the x value here, we applied some small change in the x-axis and we used h to do that. Yeah, we moved along to the right on the x-axis by some value h. So if the x value here is x and we add h, the x value here will be x plus h. So what's the coordinate of this going to be? It's going to be x plus h. And then we take that x value and we sub it into f. So if it's f of x, if we take x plus h and sub it in, we'd get f of x plus h. And with these coordinates, we can now approximate the gradient of the tangent by finding the gradient of the chord. So here's my chord. And you can see this chord is not even close to being the same as the gradient of the tangent. But let's find the gradient of the chord for now. So the gradient of the chord, remember it's the change in y or the change in x. So the change in y would be f of x plus h minus f of x all over the change in x values. Well, the change in x values is h, isn't it? Now, what did we say last lesson? We said we could have drawn a better chord by taking this point and maybe putting it here. We could have put it here instead. And if I draw the chord, you can see it's a better approximation to the tangent. If I had moved that point here, the chord would be even closer to the tangent. So the theory is, as we move our point towards the point in which we're trying to find the gradient at, the gradient of the chord gets closer to the gradient of the tangent that we're interested in. So what's happening as we move this point here towards the point in question? Well, all that's happening is we're reducing the value of h. So as it moves along, you can see the h value is reducing. So this is what comes to the general gradient function. So f dash x is, so as we reduce the value of h, we take a limit, it's called. We're saying it's the limit as h tends to 0. Yeah, so we can see here that h is some positive value, but we want to reduce it. So we're taking a limit, we say in maths, we're taking the limit as h gets smaller and smaller and smaller. And then at that theoretical 0, the 2 points, 1 and 2, meet each other, and then we have the gradient at that point. So it's the limit of this fraction. And this is the first principles formula. So the gradient function, the general gradient function, is the limit as h tends to 0 of the change in y over the change in x, and the change in y is just some small change in the x value substituted into whatever the function is to get the y value. Hey guys, I hope you're enjoying the video. If you're new here and you want more maths content, then please consider subscribing. If you're learning something, then hit that like button and comment down below to let me know what you want to learn next. I hope you enjoy the rest of the video. Something you guys need to remember. So the gradient function or derivative of the curve y equals f of x is written as f dash x or dy by dx. And then you could say dy by dx or f dash x is the limit as h tends to 0 of f of x plus h minus f of x all over h. Now the gradient function can be used to find the gradient of the curve for any value of x. Now the beauty of this formula is we don't need to draw any graphs anymore. You just need to know what the formula is for the first principles formula. So here's a standard question. Prove from first principles that the derivative of x squared plus x cubed is 2x plus 3x squared. So we have our first principles formula. Now what I like to do here is I first like to say what f of x is. So f of x is x squared plus x cubed. And then what is f of x plus h? Because then we're just going to sub it in, right? So f of x plus h is wherever you see x, you're going to replace it with x plus h. So let's now sub into our formula. So it becomes the limit as h tends to 0. F of x plus h is x plus h squared plus x plus h cubed. Then we're subtracting f of x. Now be very careful, f of x has two terms. So when we subtract, we need to keep in a bracket. X squared plus x cubed all over h. The next step is we need to expand our brackets. So I trust we know how to expand squared brackets. Now this cubic, you can obviously write 3 brackets, but we know the binomial expansion. Pascal's third line goes 1, 3, 3, 1. So we can do ascending powers of x or descending, it's up to you. But I'm going to say it's 1 x cubed, or just x cubed, plus 3 x squared h. Another 3 x h squared, plus 1 h cubed. Then we are subtracting x squared and we are subtracting x cubed all over h. Now if you've done this properly, then you should see cancellations. X squared cancels with this and x cubed cancels with this. You should always only ever be left with h terms. Now the next thing we're going to do, just like we did in the last lesson, is we're going to split the fraction. We're going to do 2xh divided by h. We're going to do 3x squared h divided by h, and so on. So we're left with the limit as h tends to 0. So if we do 2xh divided by h, then we're just left with 2x plus. When we do 3x squared h divided by h, we're just left with 3x squared. If we do 3x h squared divided by h, we just get the h squared cancelled with the h to just leave 1h left. And then we have h cubed divided by h is h squared. Now, as h gets smaller and smaller and smaller, at that theoretical 0, the terms of h disappear, and we're left with 2x plus 3x squared, and that's now proved. So the good thing about this is knowing the gradient function means that anyone can ask you, what's the gradient of our original function at 2? So it means we don't have to do this process all over again and again and again. We just find the general gradient function and we sub in 2. So if someone said, what's the gradient at x is 2? You would sub in, remember this is for f dash x, right? So you would do f dash of 2 is 2 times 2 plus 3 times 2 squared, which is 4 plus 2 squared, 4 times 3, 12, so 16. So you don't have to keep doing this whole process of the chord and any of that. We just find the general gradient function. Now this is how we do it using first principles. So next lesson, we're going to use this idea to form a general rule. This is known as the chain rule specifically, chain rule for power functions. And we're going to do this process much quicker and we can answer more exam type questions. So this is specifically how to differentiate from first principles. So guys, if you learned something today, Make sure you hit that like button and subscribe for more maths content. I look forward to seeing you guys in the next video. Peace.